Day 395 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 917, reverse only letters. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. Given the string S, reverse the string according to the following rules. All of the characters that are not English letters remain in the same position. All of the English letters, lowercase or uppercase, should be reversed. Return S after reversing it. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have the input S equals a string AB dash CD. The output is a string DC dash BA. Now, as you can see, all they did was reverse the characters and keep or reverse the English letters, and then they kept the non-English letters in the same position. So here we reversed AB to with the CD, and we reversed AB so that it became BA over here, and then we reversed the CD and put the CD over here so that it became DC over here. So if you read this backwards, it's still ABCD, just like when you read it forward in the input, it's ABCD. Now it's important to remember this dash didn't move. This dash stayed in the same position, which can be tricky, and I'm going to show you how it can be tricky and when we get to the next example. But once again, we just went from A, B, C, D reading forward, and now when we read it backwards, it goes A, B, C, D. So let's take a look at example 2 where it could get a little bit tricky with these dashes, and I'll explain why as we get into it. So with example 2, we have the input S equals a string A dash BC dash DEF dash GHIJ. The output is J dash IH dash GFE dash DCBA. So as you can see, if you're looking, it still reads the same forward as backwards, right? It goes A, B, C, D, E, F, G, H, I, J. And if you read it backwards, it goes A, B, C, D, E, F, G, H, I, J. But these dashes, as you can see, the dash is no longer in between the A and the B, right? But you have to remember the dash, when they say stays in the same position, they mean stays in the same position. Not That doesn't mean in between the same letters. That means literally in the same position, right? So as you can see, we have one character, then we have a dash, then we have two characters, then we have a dash, then we have three characters, then we have a dash, boom. And it's the same in the output, right? So we have one character, then we have a dash, then we have two characters, then we have a dash, then we have three characters, then we have a dash. So even though the characters or the letters were reversed, the dashes are in the same position, which is important to understand, which is kind of the tricky part in understanding this. So the dash is not about what letters the dash comes in between. It's about what position is the dash in to start with, right? The dash right here, if this was an array, the dash would be at index 1, then it'd be at index 4, right? And then so on, so on. Same here. The dash is still at index 1, then 2, 3, and the dash is still at index 4, then 4, 5, 5, 6, 7, then the dash is at 8. Same up here. Dash is at, this is 4, 5, 6, 7, dash is at 8, right? So the dash is still in the same position. That's what they mean by the same position. It has nothing to do with what letters it comes in between. Now, with the dashes in the same position, it still reads the same forward and backwards once again. So let's look at example 3. Example 3, they try to throw some other non-English characters in, like we have this equal sign and so on and so on. But it's the same principle, right? So in example 3, we have the input S equals testing 1. Ooh, see, 1, that's a tricky because that's not an English letter. But as testing with the 1, then leet equals code dash Q exclamation point. This time reads the same backwards, QEDO, but you see the 1, same position. Then we have the CT, Then we have the dash, EELNG, the equal sign, same position. Keep going. Then we have the dash, same position, exclamation point, same position. So this 1 is at index 0, 1, 2, 3, 4. So the 1 is at index 4 and 0, 1, 2, 3, 4. And both input and output, we have a 1 at index 4. Boom. Then we go 5, 6, dash at index 7. We go 5, 6, dash at index 7. The dash is at index 7 every time. Then we go 8, 9, 10, 11, equal sign at 12. Same down here, 8, 9, 10, 11, equal sign at index 12. Then we go 13, 14, 15, 16, 17, dash at index 17, 13, 14, 15, 16, dash at index 17, 18, 19, exclamation point at 19, exclamation point at 19. So as you can see, it might look a little, get confusing because you might think testing, or I should say testing backwards with the 1. But the 1 is not it's not an English letter, so the 1 is not going to read, or is not going to be included when we if we're reading it backwards, because the 1 is going to stay all the way up here because it's not an English letter. So I hope that made sense to y'all. It's pretty simple to understand once you kind of understand what's going on. Just remember, if this was an array, the indexes of the characters that are not English letters don't change. So just keep them at their same index that they were at before. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not difficult at all. It's not even a lot of code. Let's get started. So, and I think y'all will be surprised at how easy this solution is. Now let's get started. First thing we're going to do, we're going to say let R, and we'll just make that an array. Open up the parentheses, pass in S. So R will be an array of S. Then we're going to filter out only the letters from the array and preserve their order. So for that, we're going to declare a variable, say is letter. Then we are going to say equals R.filter. Open up the parentheses, open up the brackets, $0. This $0 represents each character in R, right? So we're working with our array R. This $0 is going to go through each character in the input, or in R and S for us, array of S. Boom. But then we're going to say $is letter. So it's going to go through the whole array and see which ones is the letter, which ones are letters. Then we're going to initialize an empty array to build the result, or our output. So we could declare a variable. We could just call it output, just to make it easier to understand. Say equals. This is where we're going to store our equal, store our output is going to be a character, an array of characters, excuse me, and we're going to initialize it with parentheses like that. Now we need to iterate over the original character array. So we're going to say for S in R, we're going to open up the brackets, and if the current character is a letter, we're going to append the last letter from letters, so we can reverse it. So we're going to start from the last letter and reverse it. Otherwise, we're going to append the non-letter characters as is. So for that, we just say output dot append, open up the parentheses, S dot is letter. Then we're going to say question mark. So if it is a letter, we're going to say letters dot or excuse me, not letters. We're going to say is letter, so is letter dot remove last, open up the parentheses, or just quote S. Boom. So if it's not a letter, we're just going to remove that. If it is a letter, we're going to remove the last. Boom. Then we just need to convert the output array back to a string and return it. So for that, we just come right here. We can return. Well, let's fix this because that's just a little, that can get a little confusing. So let's just do it like this. Boom. Then we're going to say return string, open up the parentheses, pass in output. Boom. Now that's all the code, y'all. That should be all she wrote. Let's run it. Make sure it runs properly. Expected separator. Hold on. Oh, should be a question mark right here. So let's run it again. Let's see. And it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted after we submit it. Let's see. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift. That's what I'm talking about. Those are the numbers I like to see. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.